Welcome back, guys. So today we are going to solve two questions which are related to the validity of the electric circuits. So these are question 2.2 and 2.3, and both of them are basically relevant with each other. So let me first go through question 2.2. So the statement of this question is, if the interconnection in figure 2.2, okay, so this is the figure 2.2 is valid, find the total power developed in the circuit. If the interconnection is not valid, explain it. Okay, so here this is the circuit, and we can see that there is no reason to make it invalid. Okay, I have previously told you that a circuit will be invalid if two or more than two voltage sources are connected in parallel, which has the voltage values different from each other. So it means that the different parallel voltages are connected, which is inconsistent with the rules of the electric circuit. Okay, similarly, if you have a single loop and two or more than two current sources are connected in it in such a way that all of them has the different values, so that is also the invalid circuit. But there is no connection like that one which we can call the invalid, so this circuit is the valid electric circuit. Okay, so if this is the valid electric circuit, we have to find what? We have to find the total power developed. In order to find the total power developed, we have to see that what are the sources which are developing the power. So here we have this 50 volt source, 10 volt source, 40 volt source, and 5 ampere current source. All of them are basically the independent sources. Okay, so first of all, in order to find it out, let me find out the voltage across this. So let me call it V5. We don't know its polarity, so first of all, let me apply KVL here in this circuit. In order to apply the KVL, let me consider the direction of the current. So let me consider the direction of the current, and let me take it this one, which is inconsistent with this current source. So if we have taken it, so let me use this voltage source here as well. So this is what, let me call it V40. Okay, V40, and here we can see that current is entering through negative and coming out of this source through this positive terminal. So I am taking it positive. Here we can see that current is entering through this positive terminal and coming out of this negative terminal, so therefore I am taking it negative. So minus V10 here again. So this is the anti-clockwise current, so this is entering through this positive, coming out of this negative, so I am taking it negative as well. So this is V50. Okay, so the last one here is 5, so I am taking it as it is because this one is the unknown. Okay, so this must be equal to 0. So all of these values are known except this V5. So in order to find this V5, we have here minus V40 minus V10 minus V50. Okay, so here we have, so let me put these values. So this is 40. Okay, this is negative 40 minus 10 minus 50. Okay, so this is what? This is 20 volts, positive 20 volts. So what is mean by this positive 20 volts? Positive 20 volts means that the polarity we have taken for this V5 is correct, and the polarity we have taken for this one was of similar as this V40, because both of them are the positive ones. So therefore this is now here negative and this one is positive. Okay, so this is the polarity of it. Now in order to see which are the developing and which are the absorbing sources, here according to this current, this source, because here the current is entering through negative and coming out of this positive, let me use this color. Current is entering through this negative, coming out of this positive. Here again current is entering through this negative, coming out of this positive according to this current direction. So these are this V5 and this V40, both of them are the developing sources. So in order to find the value of it, so PD is equal to what? PD is equal to the power developed across this 5 ampere source plus the power developed across this 40 volt source. Okay, so let me have the formula, and we know that P is equal to IV. Okay, here I is I5 okay, which is the current going through this source, and here this is V5. Similarly here we have I40 and V40 as well. In this series circuit we can clearly see that the current through all of these elements is the similar one, and that is the 5 ampere. So let me write here 5 multiplied by the value of V5, which I have already found out is this 20, okay, and the value of I40 is again the similar one, which is this one, a constant overall through this branch. So this one is 5 multiplied by V40, this is 40. So let me find it out. This is 100 plus this is 200, okay, so this is now 300 watts, which is the developed power through this circuit. Okay, so that is the solution of the question, because we are asked to find out the developed power and we have found out by this formula. Okay, so that is the solution of question 2.2. so now here in this question 2.3, let me solve it. So in solving this one, we can see that one current source is this one, and while the other current source is this one. So first of all we have to see that whether this is a valid circuit or not. These two voltage sources are connected here, which is completely valid. These two, one current source, one voltage source, these are connected in parallel, which is also valid because no two or more than two different voltage sources are connected in parallel. So this is a valid circuit, and also there are no two or more than two current sources which are different in values are connected in series. So here we can see that this is a valid source. After it we have to find what? We have to find this V10 and V5 as well to find out the power developed by this source and this source as well. So this V10, we can see that this is in parallel with this 100-volt source, so the polarity of it will be the similar one as that of this one, and the voltage across this one will be the similar one as that of this source. Okay, in order to find out the voltage across this V5, let me consider the current here. So this is the current here, and let me use the KVL here. So in order to find the KVL here, we have to do what here? This will be, let me consider this one as the positive, so it will be negative positive. So let me consider this one as V5. okay, this is now current is entering through positive, coming out of this negative, so this is minus 40. okay, and also as the current is entering through this positive, coming out of this negative, so this one is minus 100 as well, and this is equal to 0. So in order to find this out, it is minus 140 equal to 0, and the value for V5, once we will find it out, this is 140 volts, and this is now known. Okay, so now in order to find the power developed by this 10 amps, this is what? This is, let me have P10, and this is the I multiplied by V10. so I10 is known, that is 10 amperes. V10 is also known, and we have already found it out, that is 100, which is 1000 watts. okay, and the value of the power which this source 5 amp source is developing, let me call it P5. This is also I5 multiplied by V5. Do we know the value of I5? Because this is the current source, so that is already known. 5 amperes multiplied by V5, and that is 140. okay, so here finding it out, what will we get? It will be 700 watts. okay, so the total power developed here is PT is P10 plus P5. okay, adding them together we will get 1700 watts, and that is the solution of our question. okay, so that's it for today, in which we have seen the solution of question 2.3 and also the solution of question 2.2 as well. okay, so these are the two solutions. If you have any question regarding these solutions, you can ask me in the comment box. See you soon.